ladies and gentlemen, this is team number 8 and we want to give an audit about the comparison between the different straw materials. These are our contents. First we have an introduction, the material sourcing innovation, the sourcing energy consumption and some conclusions. Let me start with the introduction. At the beginning we have the problem recognition. So plastic straws, they are lightweight, small and flexible, and because of that we have different kind of problems. First we have the difficulties in the large industrial grade recycling machines, and because of that the recyclers mostly put the straws to the landfill. Also we have the cost problem, so that means that the use of new plastic straws are cheaper than recycling because the polypropylene is so cheap. A plastic straw can take up to 200 years to decompose, and also some information about the market growth of 6% during the next years because of the takeaway foods and the food service packaging arises. And we have a big environmental problem because of the straws. So that's why the number of reusable and eco-friendly alternatives are increasing. So now some facts about the legal situation. So we compared the EU with Korea. As you can see, the EU forbid all plastic products or many plastic products since July 2021. In Korea it's a little bit different. There the use of plastic straws in the restaurant establishments are banned after June 2022. And as you can see on this down slide, there are just 7% of the countries restricted plastic straws at the moment, so there is still really much to do. This I want to skip. Now about the raw materials, we have plastic and glass straws that makes the biggest sales in year 2018. So plastic straws are out of polypropylene resin and some additives, and glass straws are out of borosilicate glass, and there we have the problem that it's not recyclable and the recycling is not economical at all. And yeah, so that's why we decided to also have a focus on other material opportunities. But as you can see in the summary, all of these opportunities have negative things. That's for example, the paper straws are 5 times more expensive than plastic straws. They are not completely tasteless, and these other areas we have high costs. So that's why we decided to go to another raw material. And yeah, because of because they are produced out of plants, you can reduce the use of fossil fuels and the greenhouse gas emissions when you use PLA. Now the conclusions why we decided to go to PLA instead of PP. The best thing in general is not to use disposable straws. But sometimes we have to use straws because we have some persons, some older persons, for example, who need to use straws. So you have some other possibilities where you have to wash them and they are really expensive. Also, PP and paper straws are hard to recycle. And also the other possibility has problems with costs and material shortage. And yeah, PLA is eco-friendly, compostable, and the raw material is easy available. And now I want to hand over to Minyoung.
Thanks, Mark. Hi, I'm Minyoung. I will be presenting on material sourcing. There are 5 main steps to making polypropylene. After extracting the crude oil, naphtha can be obtained by refining the crude oil. Propylene can be obtained from the naphtha by steam cracking, and it is polymerized to PP. Finally, the PP is bladed to make straws. Therefore, the total embodied energy in PP manufacturing process, including the transport energy, is 99.22 megajoule per kilogram. Next is PLA manufacturing process. The cones are harvested because PLA is made from sugars of the crop. After that, it is made into starch through the wet milling, and it sacrifices starch to produce the glucose and ferments it to obtain lactic acid. Lactic acid is converted into lactide and then polymerized to PLA. Therefore, 61.22 megajoule per kilogram of energy is required for the PLA manufacturing process. And next speaker, Junhyung will sum up the total energy consumption.
Thank you, Vinyoung. From now on, I will sum up the sustainable sourcing value of each material. Firstly, energy consumption of polypropylene is the sum of the raw material manufacturing energy and transporting energy. Therefore, the total SSB is concluded as 97 megajoule per kilogram. In the same way, energy consumption of PLA is the sum of the raw material manufacturing energy and transporting energy. Therefore, the total SSB is concluded as 61 megajoule per kilogram. From now on, I'm going to talk about sourcing innovation of each material. The most preferable way is to prevent the production of plastic straw by law. For example, UK Department for Environment have started to ban plastic straw in last year. The second preferable way is to reduce the opportunity of usage. By having campaigns or education about potential danger of plastic straw, this can reduce the usage of it. The last thing is to increase recycle rate by making bundle of straws when separating garbage collection. The first sourcing innovation of PLA is to change electricity production from fossil based on renewable energy, and this can reduce 60% of total energy and about 2 kilograms CO2 per 1 kilogram of PLA. The second is to develop new technology on lactic acid production, which generates a lot of greenhouse gases. The next speaker, Youngjae, will sum up.
Thank you, Junhyuk. Hello, my name is Youngjae. From now on, let me talk about conclusions of this midterm project. First, let me wrap it up. At the beginning of the presentation, Malt mentioned many candidates for material. Among them, PLA was judged to be a suitable substitute, so we compared PLA and polypropylene through this project. As you can see this table, PLA is more suitable than polypropylene apart from both water usage. And these are the good and poor practices of those identified through the comparative process. Compared to PLA, polypropylene requires less water and has excellent price competitiveness. However, from an environmental point of view, it is very critical and it has high embodied energy. On the other hand, PLA is biodegradable, can reduce the consumption of fossil fuels, and it can be considered environmentally friendly, and also has other various good practices, such as the fact that there is no toxic gas emission during incineration. Of course, there are also negative aspects such as price competitiveness and lack of composing facilities. This is going to be the part we need to address. So, we concluded that we should use a straw made of PLA instead of PP. Stands for polypropylene. This is because PLA is superior to polypropylene in various aspects such as biodegradability or embodied energy. This is our further works for the final project. There are appendices and references at the end of the file. Thank you for listening, and if you have any question, please ask us. Thank you.